So this is one of the Georgia tasks. It's called the Orange Fizz experiment. It's using ratios in sort of a real-world situation. As such, it has a lot of critical thinking. It's going to be difficult to think through these processes. What I love about this is that it basically, instead of repeating what you did with ratios and proportions in 6th grade, it takes it to a new level so that you're actually applying these. So I don't want to start off just doing exactly what you did last year. I want to really start moving us forward and doing these in new different situations that you haven't done before. So let's look at this situation. It says a famous cola company is trying to decide how to change their drink formulas to produce the best tasting soda drinks in the market. The company has 3 different types of formulas to test with the public. The formula consists of 2 ingredients, orange juice concentrate and carbonated water. You're a scientist working for this company. You will get paid a large commission if you can find the right formula that will sell the best. Your job is to find out which of the formulas cost the most based upon their concentration, as well as which one is the best tasting of the flavors. Using the company's new formulas, using the company's new formulas, you must follow the recipe to the strict guidelines. All right, so you can read the formulas there. Now the first part we're going to do is a part to whole comparison. That's how much out of like the whole mixture, how much does each part contain. That's where you're doing your, remember, percentages are part to whole. So when it says percent, that's why. And then we're going to do a part to part. So let's look at part A. I'm going to pull it up here so I can write on it. My goal here is not to walk you through every problem. Really, I'm probably giving you too much information because your job here is to figure out what to do. If I tell you everything, then you're not really thinking. You're just repeating what I'm saying. And that's not how the real world works. The real world works where you're actually having to think through problems. So let's read this, and then I'm going to get you started. Which formula will make the drink that has the strongest orange taste? Well, I'm sure it isn't a big leap for you to know that the one that's the strongest is the one with the most orange compared to the water. Now, these look like they have the most, but they also have more water, so they may not necessarily have the most. So I'm going to compare 2 of them. I'm going to compare Formula A with Formula B. And one of the things that I love to see on these, and if you want to make a good grade on the milestone on the short answer, a great thing to do is to label things and organize your stuff. Because the easier it is for the person grading to follow your thinking, the more points they can give you, especially if you miss it. You know, if they can follow what you're doing, they can give you more points. So really try to label things. So Formula A has 1 tablespoon of orange to 2 water. So that's a 1 orange to 2 water ratio. Now we're doing orange to water, so we need to do that same ratio here. We're going to compare it to B. That's 2 orange to 5 water. And the strongest one's the one that has the highest ratio of orange to water. So let's look here. We're going to compare 1 to 2, 2 to 5. There are a couple ways you could do this. One is to reduce both fractions to simplest form and see which one. These are both simplest form. That doesn't really help us. It depends on the fraction. Sometimes that helps, sometimes it doesn't. The other thing you could do is give them a common denominator, and that's the strategy that I'm going to use. You could do all 3 at once, but I'm going to do 2 because I don't want to give you the answer. So I'm just going to do these 2. The smallest, you're basically going to act like you're adding these fractions. You find the smallest thing they're both going to, which is 10. And just as if I were adding them, I'm going to find 2 equivalent fractions. We're going to say, what times 2 makes 10? Well, 2 times 5. Just to make an equivalent fraction, I have to multiply the 5 here. 1 times 5 is 5. So that's 5 tenths. We do the same thing here. What times 5 makes 10? 2. Well, I have to multiply 2 here too. 2 times 2 is 4. So 5 tenths or 4 tenths? Well, based on this, it looks like Formula A is stronger because it has a higher ratio of orange to water. There's more orange for every bit of water in there. So right now, A is higher than B. So you know, for part A at least, B is not the answer. So now all you have to do when you get to class is compare A with C to see which one's the strongest. Now, I probably helped you too much on that, but I want you to get off to a good start. Now it says, which formula has the highest percentage of carbonated water in the mixture? Estimations may be used to show your work and justify your answer. So just one note I want you to make so that you remember is percent means is a part to, and I'm sure you already know this at this point, part to whole. So you're trying to find the percentage. In this case, it says the percentage of carbonated water. So since it's the percent of carbonated water, I need to get the part that's carbonated water, which is 2. To the whole mixture, let's see, in the mixture I have 2 tablespoons here to 1 tablespoon there. So 2 out of the whole would be every 3 parts. So 2 out of 3 parts is carbonated water. And so at this point, we just change that to a percent. And we've done this a few times now. You know that a fraction bar means to divide. 3 over 2. There are other ways to do this. We've discussed those in class, but I'll just do it this way to keep it simple. 3 doesn't go into 2, so we add a decimal 0. 3 goes into 26 times. That's 18. That leaves us with 2. And it looks like I'm going to keep getting 6s because that's a 20. So I'm going to keep getting 6s. So let's, first of all, since it's a percent, we have to move our decimal 2 spots. Put it there. So it looks like this is about 66%. And since it said estimations could be used, I'm just going to round 66. Or since that's a 6, I'm going to be a little better and round to 67% because this next number is higher than 5, or it's 5 or more, so 67%. So formula A, carbonated water is 67%. And I'd really like you to label it and be a little more organized. I'm kind of everywhere, but it's because I'm trying to write big to show you. So keep it nice and organized as you're doing yours. A, show your work. B, show, and then you can answer the question. And when it says justify your answer, that means you're going to write a little bit. This is why I put what I put. You need to have words, a sentence there. So maybe make a note. I need some words here. And once again, you're not doing this tonight. You're doing this tomorrow in class. All you're doing tonight is getting this introduction. So if you're trying, I don't want you to try to finish these problems. I just want you to make these notes and get the introduction down. All right, let's look at the next page. So this is the part to whole, to part ratio. So now they're going to try to make enough for 100 people. Each sample contains 1 cup of liquid. So here's formula A. If you mix 1 cup of concentrate to 2 cups of water, you're going to get formula A's mixture. Now that's down here's where they did formula A, and formula B and C will be in different tables. So that's what you're going to do. I'm going to help you with A real quick. So for A, here's the original mixture. For every 1 cup of water, you do 2 cups of carbonate. Sorry, for 1 cup of concentrate, you do 2 cups of water, and that makes 3 cups. 1 plus 2 makes 3 cups of serving. That's only if you're serving 3 people, you'd have enough. But they're serving 100, so you're making this table to get up to that 100 servings. So you see here, now if we double this and do 2, we double this, we get 4, that makes 6 cups. Well, if we triple it, that's 3, which means we triple this, we get 6, that makes 9 cups. And I really don't know what they wanted you to put here. I'm just going to make up a number so I could show you. Let's say we did it times 4. We did 4 cups of concentrate. Well, if we do this times 4, we do this times 4. So what would that be? It would be 8 cups, which makes how many cups? Well, a total of 12. 8 plus 4 is 12. 12 cups, which makes...
I'm sorry.
All right, so we got 12 and 12, and I just made up the 4 and 8. All right, so once again, I just put in the 4 because I wanted to show you. I think you're just will leave this blank. I don't even know. We'll talk about that tomorrow. Then they're showing you they skipped a bunch. They skipped up to 17. So if you did 17, that means that the concentrate you're actually multiplying by 17. But you got to do the same thing here. 17 times 2 is 34, which makes 51 cups. 17 plus 34 makes 51. So let's get to where we're actually filling in the blanks here. So I'm going to skip this line. This is done, only it doesn't have the servings. So let's look here. If we have 33 cups of this, 66 cups of that, well, if I put those two numbers together, it looks like it's 99. So that would be 99 cups, which would make 99 servings. And we're going to keep going here. So now if we have 34 cups of the concentrate, well, how would I get from 1 to 34? 1 times 34. makes 34. So if I want to get this blank here, I need to do the same thing to the 2. So I'm going to do 2 times 34. And 2 times 34 be 128, I believe. No, sorry. Got distracted there. Let me delete that. It'd be 2 times 4 is 8, 2 times 3 is 6, 68. Sorry about that. 34 plus 68 would be and so what I'm doing is I'm adding these two together to get the total cups, because there's 68 cups here, 34 cups here. That's what's going to go here. That's 102. So that makes 102 cups, which would be 102 servings. I'm going to switch colors just so I have something that stands out. Now this is a little different, this line. Here they had 1 and it was easier because you know 1 times 34 is 34. Here it's 2, so you need to know, all right, what would we do to 2 to get 70? 2 times what makes 70? Well, I believe it's 2 times 35. Let's check that and see. 35 times 2. 2 times 5 is 10. 6, 7. Yeah, that's 70. So it looks like we're multiplying by 35. So I need to do the same thing here. 1 times 35 is 35. If I add 70 plus 35, I get 105 cups and 105 servings. So now here's the question, once we've done that. How much orange concentrate and carbonated water is needed to serve at least 100 people? So we've got to serve no fewer than 100. So right here we're serving 99, so we're 1 short. Since we have to keep that same formula, we have to go up to the next level, 34 and 68, which would be right here. Now we're serving extra, but we have to have at least 100, so it's fine to go over 2 people. We just can't go under. So it looks like we need 34 cups of concentrate, and let's see, 68 cups of carbonated water. And so now you're done with A. So what you're going to have to do is the rest of that paper. This is just the intro, so you're going to need help with this, and that's fine. Just hopefully you picked up how to start so that we don't have to go over all this with the entire class, and you can get started when you're ready to, rather than waiting on everyone else to get ready. And then ask for help, please, as you need it.